In the previous video I made the PTFE anti-backlash nut blocks, and in this video I'll now assemble the X and Y axis as well as making the locking collars for the ACME threaded rods. So when I bought the parts for the machine I used Aliexpress for the smaller items which I could buy in bulk, saving quite a bit of money, but I decided to get the ACME rods and the aluminium extrusion from a local company called Ooznest. I'm now at a stage where I can start assembling the X and Y axis of the machine, but I want to try think ahead and avoid dismantling the machine at future stages if I can help it. So the first thing I'm going to do is fit the Z-axis C-beam to the gantry plates. I haven't finalised the plates for this part, which is what I'll be working on in the next video. This machine will use 3 500mm 20x40 aluminium extrusions, 3 500mm C-beams and 1 250mm C-beam. I decided to make a smaller machine first as I don't want to start cannibalizing the X-carve and realise I still need it to cut parts out. Here I'm struggling to fit the gantry plate assembly on the C-beam, and this was because I hadn't tightened the machine screws so they would clear the aluminium. Once that was done it went on nicely and I could start tapping the holes of the aluminium extrusion. The C-beam mounting holes were already tapped, but I'm using longer machine screws so I need to extend them. I then placed some T-nuts on the underside of the X-axis, which will hold additional brackets to the Y plates. The flaming caliper suggested this to me in a previous video and I thought it was a good idea. I then screwed the Y plates on the C-beam using the drill to do most of the work and an Allen key to finally tighten them. I'm using stainless steel machine screws, which don't feel as hard as the high tensile variety. I then marked the bracing aluminium which will fit between the bottom ends of the Y plate and cut that out on my miter saw, which was coincidentally made on a CNC machine. I tapped the holes and fitted this on. The bottom brace along with the aluminium corner bracket, which will eventually go under the thick C-beam, will all help prevent play along the X-axis. I then slid the Y-axis in place and assembled the base of the machine. This was pretty straightforward as the end plates should pull everything together and square the machine, providing they were cut square. I placed the T-nuts on the machine screws through the plates and then slid them onto the aluminium extrusion, lining up the holes of the C-beam and screwing them in place. I did place some more T-nuts on the underside of the Y-axis C-beam, which I'll eventually attach some flat aluminium brackets to. These are still on the X-carve and I'll have to finish this later. So I'm losing a bit of movement because the 40x20 aluminium extrusion is actually a little bit longer than the C-beam. So I'm going to mark these, pull them out and then cut them. .494. I reassembled the machine and tested the movement by holding the Z-axis and waving my hand around uncontrollably. The axes are very smooth, although a little more so on the Y than the X. I will have to readjust the eccentric spaces on the gantry plate assembly at some point. Once I stopped enjoying the success of the moment, I noticed the X-axis was not square to the front of the machine, or the back for that matter. I'm getting contact here, but on the opposite side I was getting a 1.5mm gap. While the lead screw would eventually force this into place, I'd like to try assemble the machine as square as possible. I decided to remove the bottom brace and recheck the gap in case anything changed. I could have cut that at a slight angle by accident, but it didn't seem to do anything. I also checked if the frame was square, which it was. It is more likely that the plates might have warped a little or the C-beam was cut a little off. There's not much I can do about the plates as they are birch ply. But while checking the C-beam, which was fine along the long edge, I noticed it was a tiny bit off along the short. I decided to cut the X-axis C-beam and Y-plate brace at the same time on the table saw so they were identical and see if that made a difference. The smaller piece went neatly between the C-beam, and while feeling the ends I could tell they weren't the same length either. So I've made this corner bracket which fits onto the back of the sledge. So I'm pushing everything against this end here, and then I'm going to clamp it down. I ran the pieces past the blade, taking off a shaving and levelling one side. I then flipped it around and did the opposite end. By cutting these pieces, I noticed that the tapped holes on the other C-beams were slightly raised, and these had been removed by levelling on the sledge. You can hear my nail getting caught onto something. Cutting the two pieces together seems to have reduced the gap to less than 0.5 mm, but I then noticed the plates were a little skewed along the X-axis. I hadn't checked this before, so I can't compare. I used the bevel box to level the blade on the table saw, but my fence may have warped over time. I could just live with this and level the spindle to the wasteboard when the time comes, or I could flip the C-beam upside down and see if that changes anything. They're still at an angle, so I'm going to take the bottom ones off as well. So it's the plates, it might be the wheels. I'm really confused. I was hoping it would pull itself. Okay, I've adjusted the wheels a little bit and they're still the same. So I think what I'm going to do is when I go to fit the spindle on, I need to make sure that this Z-axis C-beam is square to the wasteboard, and to do that I need to be able to access all the machine screws which hold it in place, and there's two which happen to be right behind the C-beam. So I'm just going to drill a small hole somewhere along the middle where I can adjust my machine screw. So there's still a gap. I've swapped this around the other way. It's definitely the plate or the wheels. I don't think there's anything I can do about it. So as long as I can make sure the Z-axis is square, it shouldn't really make too much of a difference. It's a little bit off, but this and that will keep it in position. Okay, so I can loosen this part here and adjust it to the left and the right, which means I can compensate for the tilt in the plates. I'm now going to make the ACME locking collars, and I'm going to use a 14mm aluminium round bar to do this. After deciding on the measurements, I cut a small section off on the table saw. Because the piece is round, you really have to clamp it down, otherwise it will spin. I made a 15mm segment which I drilled out to 8mm on the lathe. I know I'm using a wood lathe for this, but you can also drill these out on a pillar drill if the piece was carefully secured in a vise. I then tapped and drilled the holes which will hold a 6mm M6 grub screw, which is how I'll secure these to the ACME threaded rod. When one worked, I made the rest and assembled the lead screw on the X and Y axes. If I had a metal lathe, I could have taken off a bit of aluminium here to create a step which would do a similar job as a washer. I just tried to reduce the diameter of these washers on the lathe and failed miserably. So this is starting to look more like a CNC machine. It's a shame that the plates were a little bit off, but I think they'll be rigid enough and I'll be able to adjust the Z-axis to still make the next set of plates. So in the next video I'm going to make the plates for the Z-axis and install the spindle. Thanks again for watching, and if you enjoyed this video please leave a comment down below and sacrifice a thumb. If you haven't done so already, you can support this channel by sponsoring future videos, the link to which and the other usual things will be on screen now.